Today we will explore the FINEX process, an advanced iron making technology developed by POSCO and Primetals. Unlike traditional blast furnaces, FINEX uses iron ore fines and non-coking coal directly, eliminating coke oven and sintering. Commercial plants like FINEX 2 and 3 in Korea have already proven its success. Coming to our next slide, which is on the Phoenix iron making for the 21st century. The Phoenix represents a bold leap into future-ready steel making. Developed with the POSCO, it's only technology of its kind in operational globally. Recognized as a core national technology in Korea, Phoenix is not just innovation, and it's a strategic transformation for Korea, and now this technology also building across the world. Now, as far the core concept is concerned, the Phoenix process unfolds in two key steps. First, iron ore fines are reduced in a fluidized bed reactors, and then the reduced iron is melted in a separate melter gasifier. This design allows direct use of low-cost raw material and lays, which is the main foundation for the POSCO's hydrogen-based HyREX technology also. Now coming to the reduction routes, if we see in the fluidized-based reactor in Phoenix, fine iron ore is pneumatically fed into the tall fluidized-based reactor, some reaching 27-meter height. Now these reducing gases flow counter to the ore fluidizing and reducing it step by step at 700 to 800 degrees. And the final product is the hot compacted iron, which is also called as HCI. And as we can see this in the process flow diagram, this diagram shows the full flow. Iron ore enter into fluidized bed, coal is briquetted and fed into melter gasifier, and HCI is compacted and melted. Export gases and hot metal are the key output, which are clean, efficient, and of high quality. Now, as for the reduction towers is concerned, let us closely look. Let's zoom into the reduction towers. These massive cylindrical reactors fluidize the ore using reduction gas. The temperature is carefully controlled to prevent clumping. The result is uniformly reduced iron and compacted into HCI for the next stage. So in these fluidized bed reactors, basically the regulation of temperature is supposed to be key activity to have a best result. So, as far the coal route and melter gasifier operation is concerned, uh, these are basically using non-coking coal, and HCI are charged simultaneously from the top of the furnace with the charging devices like a gimbal top, and from the bottom of the gasifier we are injecting pure oxygen. So this oxygen injection combusts the coal, generating heat and valuable reduction gases, mainly carbon monoxide and hydrogen. This gas is then recycled back to the reactors, completing the loop. And a part of the gas which is remains after reducing this FBR, they taken for use in power plant. As for the melter gasifier is concerned, this is called as a melter gasifier and energy generation center also. The melter gasifier stand nearly 90-meter tall and inside coal combustion at over 1000 degrees centigrade, which dissociate hydrocarbon into carbon monoxide and hydrogen. This gas actually powers the reduction cycle, while the heat which is available at the combustion point when oxygen passes through the two air and it create a heating effect there, it melt the iron ore and it final product becomes a hot metal and slag. So now coming to the our next slide, which is about a final product. The final output is the molten iron and hot metal identical in the quality of blast furnace output. Now coming to the our one balance sheet, which is also indicates a lot on our material balance. So we can go through this material balance sheet and we can see that coal consumption is about around 720 kg per ton of hot metal. This is a very important index, and apart from that there is a reduction gas is also having got a lesser SOx and NOx level, and it is also uh, highlight is there that CO2 also can be cut up by 50% with the CCU, and CCU is also attached in the system. As for the key byproduct is concerned, as we come across a lot of time that clean export gases usable for electricity or chemical synthesis. FINEX also integrate PSS system, as we have already mentioned, PSS system to capture the CO2, enabling up to 50% emission reduction. It is not just efficient, it is environmentally responsible system also. Now, as for the benefits and conclusion are concerned, to summarize, Phoenix actually enables direct use of cheap raw material that we have already seen, and it produces a blast furnace grade hot metal and generate clean export gas. With over 40 million ton produced, it is a commercial success and a stepping stone to HyREX hydrogen steel making also. Uh, as for the recent achievement is concerned, in 24-25, FINEX 3 hit 5,760 ton per day. POSCO's carbon emission is also dropped below target. Many AI models like CNN, LSTM, they improve the briquette quality by 30% because that is also important because coal and iron ore both are charged after making compacting it and making a bigger size. So Phoenix is evolving. We can say that Phoenix is evolving with a smart control also and deep learning. As for the cost and environmental benefit is concerned, compared to blast furnace, Phoenix cuts production cost by 85%. So it is a big value. And as far as the SOx and NOx is concerned, or fines is concerned, these are significantly lower. It also uses the cheaper iron ore fines and bituminous coal even, making it both economical and clean. Phoenix is central to POSCO's carbon neutral roadmap. 10% reduction by 2030 is their plan, 50% reduction by 2040, and net zero by 2050. So, like technologies like CCUS, EAF, and hydrogen injection are being integrated. HyREX built on FINEX will be commercial before 2030. This is as for the POSCO. As for the HyREX pathway is concerned, a bit focus on this because this is one of the most very important technology coming up, and hydrogen is going to have a key role. So HyREX is the POSCO's next generation hydrogen iron making platform, and it is based on the FINEX fluidized reactors only. So a 300,000 ton per year demo plant is planned at Pohang, and it is backed by a Korean strategic tech initiative, marking a global shift in sustainable steel making. As for the future outlook is concerned, the FINEX is at the heart of POSCO's decarbonization strategy. This is known to everyone. With global partnership and expansion plans, POSCO aim for 10 million ton of hydrogen-based steel by 2030. This is the planning of POSCO. And so we can say that FINEX is a good enabler in today's sustainable steel making.